All right, so let's take a look at some problems here on Edge Elastic, a little bit more trickier modeling problems. It says, what is the approximate volume of the bullnose aquarium to the nearest cubic inch? So I apologize if it's hard to see here, but this bullnose aquarium means that it's not a straight rectangular prism like you might expect most aquariums, right? So this edge goes to here, and then it rounds off at the end. So if I create I guess it's going to be a rectangle or a square at the top there. And if I drop it down, right, hopefully you can see that this part of the aquarium is a rectangular prism. Okay, so we're going to find that by using the formula volume equals volume of a rectangular prism equals area of the base times the height. And again, your base is just a rectangle, length times width times height. That's all. All right, so what is the length going to be? Well, typically I let this be the length. And the issue here is that this 48 goes all the way to the end. Now, the one thing I did not do is I did not talk about this part yet. So this is a half circle. This base at the bottom is a half circle. If I connect them, that's going to give me half of a cylinder, right? So along with the volume of a rectangular prism, the other part of this is half the volume of a cylinder. So keep that in mind, that we're going to find these two volumes and add them together to get the total. Now, going back to here to find this length, right? The length of this rectangular prism just goes from here to there. This 48 goes all the way out to here. How are we going to find this? Well, if you scroll up in this figure, this extra distance here is the radius of that half circle. And that's very difficult to see. So that's why I'm telling you. So that's the radius. So if we could find the radius of this half circle, we could subtract it from 48, and that would give us just the length of that part of the rectangular prism. Well, to find out what this radius is, we're going to use this diameter, right? This is a diameter, and it's going to be the same thing as this edge, 24. So the diameter of this picture is 24. So the radius would be half of that. The radius would be 12. And if the radius is 12, to find that length right there, take 48 minus 12, and that's 36. That is this length right here, 36. So now to go back to finding the volume of my rectangular prism, to find the volume of the rectangular prism, it's just going to be 36 times the width. The width is going to be this 24. Again, this 24 can be down here as well, times 24. And then the height. And the height I would suggest is this side here, which is 24. So we can find that easy peasy. All right, now what about the volume of the half cylinder? Well, that's going to be half pi r squared h, right? So half the volume of the cylinder will be 1/2 pi. We just identified the radius as 12 squared, and the height is the distance between these two half circle bases, which would be that 24. And we're going to take these two and add them together, and that's going to be our final answer. So let's go do that in Desmos Graphing Calculator. All right, so here we go. We're going to take 36 times 24 times 24. That's the volume of the rectangular prism portion. And add 1/2 pi times 12 squared. No, capital, sorry, pi. 12 squared times 24. And it said round to the nearest cubic inch. So we're going to look at this. The 4 is where we round to. So look at the 6. And the 6 is going to round the 4 up to a 5. 26165. And that would be cubic inches. 26165 cubic inches. So if I go back to Edge Elastic, 26165, and that'd be cubic inches. The cubic inches are at the bottom, right? All the cubes at the bottom. So be aware of that. All right, great. Next problem coming. So we have a full waterbed mattress is 7 feet by 4 feet by 1 feet. If water weighs 62.4 pounds per cubic foot, what is the weight of the water in the mattress to the nearest pound? So this problem, I'm going to assume that the waterbed is a rectangular prism, because again, that's what most mattresses are. So this is a volume of a rectangular prism problem. Area of the base times the height, again, length times width times height. So just take those three numbers and multiply them 7 times 4 times 1, and that's 28 cubic feet. But that's not the question. They don't want the volume. They want the weight in pounds. So they give us this conversion right here. I think of this as a density, right? That's weight per volume. Again, density is really mass per volume, and pounds is not necessarily mass, but that's another story. That's a science story. But in the end, if every cubic foot is 62.4 pounds, how many pounds is 28 cubic feet? You just take these two numbers and multiply. 28 times 62.4. 28 times 62.4. And I got 1747.2. It says nearest pounds, so this 2 does nothing to the 7. So 1747, and that would be in pounds. Pounds is a unit here. 1747, and pounds is right there. There we go. So again, there was a density question in Delta Math. So if that confused you, hopefully this brings some light and you can go fix that real fast if you weren't able to do the problem. Okay, last one on this video. Let me erase that. There we go. So it says the volume of a cylinder is 135 pi cubic centimeters. The height of the cylinder is 15 centimeters. What is the radius of a base of the cylinder? So this is actually a working backwards question, right? It involves a cylinder. So volume of a cylinder is area of the base times the height. That is pi r squared h. So in this case, they give us the volume. We need to find the radius. So this is like a working backwards question. It's a true algebra question, all right? So the volume is 135 pi. That's equal to pi times the radius squared. We don't know the radius squared. So let that be x squared. And then we do know the height. The height is 15. Well, what's nice about them giving us the volume in terms of pi is that the pi's will cancel. So there goes the pi's. And now our question is just 135 equals x squared times 15. To get rid of the 15, we're going to divide by 15. 135 divided by 15 is 9. That equals x squared. And now we're going to take the square root. Again, if you're doing a pure algebra problem, you'd get two answers, plus or minus. But because this is geometry, we just want the positive answer. And the square root of 9 is 3. That is your radius, 3, and then it'd be in centimeters. Not centimeters cubed, but centimeters. 3 centimeters. Right there. Great. Okay, so there is this video. We have one more video coming up with the last two problems.